Hello everyone, we are going to be factoring perfect square trinomials. So today we will be doing perfect square trinomial factoring, okay? So there's a few things to know here. Here in this formula, okay, you're gonna take a look, it's already highlighted. The first and last terms of this trinomial, right? The first, second, and third term, the first term and third term are perfect squares, meaning that some number squared will create a perfect square, okay? Don't get too afraid of this formula. I'm going to break it down step by step as we go. But just note that the first and third term are perfect squares, always, okay? That's what makes a perfect square trinomial very different. The first and third terms are perfect squares. Let's take a look at that. That's actually the first step to identifying if something is a perfect square trinomial or not. You have to identify if your first and third terms are perfect squares. So let's look at our first term here in this new trinomial that I just wrote. 9x squared minus 12x plus 4. Our first term is the 9x, okay? And yes, it is a perfect square because its square roots are 3 and 3. And also, we're going to put the x there because actually x times x will give you x squared. So we know our first term is a perfect square, and we know our third term is a perfect square because 2 times 2 gives you 4, which is a perfect square. So we know that our first and third terms are perfect squares. As noted also in our formula, the first and third term is being squared. So we already know that whatever we are looking at is going to be squared already inside of our trinomials. Alrighty, we've identified the first and third terms. If they are perfect squares, then we are good to go. The next step we have to do is we have to take the square root of the first and the third term. The square root of the first and the third term. Multiply them together. Multiply them together, then that product you're going to multiply by 2. After you complete that process, if you end up with the exact same number as your second term, you know that you have a perfect square trinomial. Let's see what that looks like. Okay, so I'm going to take the square root of 9x squared. Okay, the square root of that is 3x. And I'm going to take the square root of this 4, which is 2. I'm going to multiply them together. That's going to give me 6x. Now remember I said you multiply the square roots together? We've just done that. Okay, now that product, that 6x, you also have to multiply that by 2. And if this number that you get gives you your second term, it can be negative or positive, it doesn't matter. Just as long as it gives you the coefficient of the second term, then you know that you have a perfect square trinomial. That's how you identify it. Now, once you identify it, then you can factor it, okay? And it's very similar to Dopp's factoring. I'm not sure if you've noticed that, with just slight variations, okay? So let's get into it. How do you factor a perfect square trinomial? But first, let's create some space so that we can do that, okay? I'm just going to split this thing in half. I'm going to do the factoring on my left side. I'm going to do the factoring on my left side. Alrighty, so in order to do this, the first thing I'm going to do, like every other factoring problem, is create my sets of parentheses. Alrighty, now that my parentheses are created, I'm going to take the square root of this first term and place it inside of both parentheses. So the square root of the first term is going to go here, and the square root is going to go here, right? So let's do that. That's 3x. That's the square root, 3x. Now, interesting enough, if you notice, you see this negative 12x here? We're going to take the sign of this term, of the second term, always for perfect square trinomials. Just take the sign of the second term and place it in both parentheses. You say, how do you know that? How do you know that works? Well, take a look back to our formula. The sign of the second term will always determine what is going to be written when it's factored, as you see. Let's take a look at the top formula. See, there's a positive sign at the second term, then there's a positive sign going to be everywhere else as well. So you always take the sign of the second term, just a good rule of thumb, and that'll make things a whole lot easier for you. Okay, so last but not least, you take the square root of the third term and then place that inside the parentheses as well. Okay, so the square root of that is 2. Alrighty, and so I'll just actually label square root. So we can remember we took the square root, right? We took the square root. And it is a square root that we put inside of both terms. Alrighty, now we have something like, it looks like one of these, okay? It looks like one of these. And if you notice, you can quickly determine which one it is in factor form. It's actually the bottom row. It's actually the bottom row. If you notice, it's the same thing twice. A minus B, A minus B. 3x minus 2, 3x minus 2. When you factor a perfect square trinomial, it is going to repeat. That's how you know it is a perfect square trinomial as well. Your factors are repeating. And then last but not least, we want you to write it in this format. Okay? So therefore, you open up your parentheses. You just rewrite what you have, 3x minus 2. But instead of writing it twice, they square it. Get used to this notation because on a lot of exams, you'll see them, instead of writing it twice, they'll just write it one time and square it, letting you know that it's a perfect square trinomial. Only perfect square trinomials can be written once as a binomial, then squared. Okay, so this binomial squared creates a perfect square trinomial, all right? And that's through the process of FOIL. Hopefully you know how to check this, also to see if it'll get you back to your original equation. So it's always good to, your original expression. It's always good to factor, but then be able to do the reverse process through foiling. So if you don't know how to FOIL, watch one of my old videos and you will learn how to do so. So this is the problem completely factored. And that formula was a little scary, but we broke it down and we allowed you to get there. So I'm going to give you one more perfect square trinomial. And then we're going to prove how we can identify it. And then we're going to solve it. Alrighty. Get ready. See, it is not as scary as you think it is. Ready? We're going to get that line back in there. Alrighty, are you ready? Let's go for it. Okay. So I'm just going to write my trinomial, and always remember that you must first identify if it is a perfect square trinomial or not first. So this is my example. I'm going to step back and allow you to do your work. Pause the video so that you can give it a try using everything that you just learned. And then unpause the video to see if we get the same factored expression. Alrighty, first thing I'm going to do is identify as a perfect square trinomial or not. So my first term is a perfect square, yes, because x times x gives you x squared. And my third term is a perfect square trinomial because 2 times 2 gives you 4. So I know I'm working with my first and third term, which are perfect squares. That's my first check, so I'm good to go there. Then I have to take the square root of those terms. So the square root of x squared is x. The square root of 4 is 2. So I'm going to multiply them together. Okay, that's going to give me 2x. And then I take that product and multiply it by 2. If it gives me my second term, I know I am working with a perfect square trinomial, but it must meet this criteria, okay? The first and the third term are perfect squares. When you take the square root of the first and third term, multiply them together, you then take that product and multiply by 2, gives you your second term, you're good to go, okay? Also, one other interesting thing to note on perfect square trinomials, you see the formula again? We're going to go back to the formula. You see this back sign here? If you notice in both of them, it's always positive. It's always going to be positive. So if that third term is negative, you are not working with a perfect square trinomial. This is the formula. It's always positive. Now, the sign of the first term can be negative or positive. That's fine. But the third term must always be positive, okay? So we have identified our perfect square trinomial. It meets all of that criteria. And then now we are going to factor. Okay, so yes, I know you're like, this is a trinomial. Some of you may even be trying to use trinomial factoring, but do not try trinomial factoring. That will not work here. You have to use perfect square trinomial factoring, right? So the first thing is create your parentheses, just like every other type of factoring. You put the square root of the first term inside of the parentheses, both of them. You take the sign of the second term, put it in both parentheses as well. And then you take the square root of the of the third term, and put in your parentheses. Again, it's going to be rewritten as a binomial squared. And we can check this through the FOIL process if you know how to do that. Again, FOIL to check your work, but that's in a later video. Alrighty, I am done here. We have factored perfect square trinomials. And do not be afraid, okay? Do not be afraid. It is different from trinomial factoring. This works on different types of trinomials, right? But you have to first identify if it's a perfect square trinomial or not. It doesn't matter if the trinomial begins with x squared, has a coefficient of 1, 2, 3, 4, 5, 6, 7, 8, whatever. As long as it's a perfect square in front of that x, you're good to go. To the left of the x, you're good to go. And if it's a perfect square all the way in our third term, you're good to go. Then you perform the check that we did over here, right? Sorry. Alrighty. And that concludes my video. Rewatch it if you need, and see you later.